Hi, good morning friends. I am Pranav Sharma. Along with Kai Zhao, we present our project on PMU placement problem in power system. First, Kai will discuss the background, motivation and the problem formulation for our project.
I'm Kai. There are four parts of our presentation: background, problem and model, case study, and conclusion. Let's go to the background first. We need to know two things: power system and PMU. Power system delivers electricity to our home. It can be represented by the one-line diagram. And the PMU is a measurement device to help the operators know the power system, so operators can keep it safe, and the system can deliver power continuously. So why we want to use the PMU? It's because it's faster, more accurate than the traditional device. We want to know the power system, but we cannot install PMU at each node. There comes the problem. Why don't we just install PMU at each node? Because of money. PMU extremely expensive. According to a report of Department of Energy, the overall cost for a PMU is 100,000. Further, it's not necessary because we can know the system without all nodes are monitored. For example, if node 2 has a PMU, then we can know node 1 and node 3 because they are directly connected to node 2.
Thus, our model look like this. Our objective function is to minimize the cost of PMUs or the number of PMUs in the system while satisfying the constraint of network observability. To form it mathematically, we'll take the example of 5-bus system. So, in the same system, here each node can have a PMU at its location. So, we'll create a binary decision variable corresponding to each node, which is saying whether to have a PMU or not. And our constraints are like that each node should be observable, which means the node itself or its neighbor should have a PMU. To how this problem will look mathematically, we'll show this by this same example. So our objective function is to minimize the cost of x1 to x5 while satisfying these constraints. To take this example of first bus, so in order to make node 1 observable, either 1, 2, 4 or 5, one of them should have a PMU, thus it should be greater than or equal to 1. We'll solve this case and we got some good results that out of the 5 only 2 nodes need to have a PMU. Now the point come, we can eyeball this solution also, but this is not the case with real power system. Thus we'll take an example of 39 bus system where we have taken the New England system. So these data are available in open source for lot of power system cases. So we took this example. So this table show the connections between nodes. Thus we wrote a program where we can automate the process of writing the constraints and the objective function. Here we are making the system matrix such that it account for all the constraints necessary. Solving this optimization problem, we had following results. So this is an illustration of 39 bus system, and after running optimization we identified 13 locations where we have to place PMU in order to make the entire system observable. This is 1/3 of the total number of nodes we have. Thus we have a saving of around 66%. But now we take a real example, even better. We take the entire European grid where we want to find the location of PMUs. So this grid have around 9,241 nodes and around 16,000 connections in between. And our objective is to identify minimum number of nodes such that we can make the entire system observable. So this problem otherwise challenging, but we automated the program so that we can solve this problem in minimum time and with minimum manual effort. So this is an illustration of this 9,000 bus system, and after running optimization we were able to solve this problem right from scratch in less than 1 minute. And we identify 2,580 locations where we have to place PMU in order to make system observable, and that is roughly 80% of cost reduction. So to conclude our project, our objective was to identify location for PMU placement such that system become observable, yet we minimize the number of PMUs needed. And we took a small example and a very large case, and we were successfully able to determine PMU locations. Thank you so much for your attention. Please let us know if you have any questions or queries.